Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, and in this session we'll show the use in HSM of morphed and offset cutting. What I'd like to do in this particular part is I'd like to first machine this particular area here, and I'll be using morphed cutting for this operation. What morphed cutting actually does, it'll actually take one boundary and then the other boundary, and it'll actually work from one boundary to the next boundary, eventually also working in that particular shape also. We'll start my operation, and in my operation I'll choose HSM, and I'll choose the option of morphed machining. The tool that I'll be using will be a 6mm ball and mill, and we now go to our drive boundaries. Now our drive boundaries actually we have to define from what boundary to what boundary we want to work to. I'll choose my first curve, and my first curve in this particular case will be this edge over here, and we should also note the direction that we're working in. I'll simply accept that boundary, and my second curve will be this curve over here, and since we have to work in the same direction, I'll simply reverse the direction and accept that. Now in my constraint boundaries, at this point I'd like to use my entire part, so I'll simply say create automatically, and right now we'll be using the boundary around the entire part. Now let's go into our passes area, and in our passes area we'll be using a step over of every millimeter. But one thing I still want to note also is I'll go back into my drive boundaries, and we also have control of our cutting direction. We can either work across, as shown here, or along our tool pass over here. Now, in this particular case, I want to work along. Now, if I go into my links, I can work one way or bidirectional. In this particular case, I'll be working bidirectional, going back and forth. And after we calculate our part, we'll take a look at our simulation, and we'll see in the simulation itself that the tool starts from one area and slowly works over to the second shape over here, covering this entire area over here as shown. Now what I'd like to do now is I'd like to work in this area, but I don't want to work on this particular stub that we see over here. So I'll go back into my operation, and this time in my constraint boundaries, instead of using create automatically, I'll choose the option of create manually. And when I create manually, I'll simply define, and what I want to do is I want to use this particular area over here. We're having this as one boundary, and this area is the area that I don't want to machine. And I will be using obviously the morphed option. I'll simply accept these two chains, and this time what I'd like to do in my drive boundaries, I'd like to work across the part itself. I'll keep the same passes of a step over of 1 millimeter, and I'll leave my links at bidirectional. I'll simply do save and calculate, and this time when we look at our simulation, you'll note that the tool will work across the part as you see here. And when it gets to these areas, it will simply skip around those areas and then complete the entire part until the very end using the morphed machining. I'd like to continue working on this part, and I'd like to work in this area over here, and I'll use the option called offset cutting. If I use this option as shown here, I'll choose the option, like I said, offset cutting. I'll use my tool, the exact same tool I used last time, of a 6mm ball and mill. And the idea behind offset cutting is I can simply pick a boundary, and I can work a designated distance off either side of the particular boundary. And in my drive boundary this time, I would like to use this particular curve over here. And note also the direction that I'll be working in. Now, we have here the option of working either across or along, parallel to the geometry that I've chosen. And the next option we have here is also clear direction whether I want to work to the right of the part or to the left of the part. In this particular case, I'll read or I can actually go in both directions. In this particular case, I want to work right now only to the right. Now, if I go into my constraint boundaries, I'll use create automatically. And in my passes area, I'll have my step over of every millimeter. But we have here what we call clear offset. And I have actually right clear offset since I'm going to my right. Now I can write a value in over here of how much to the right I want to go off, or I can simply click on the button and simply click on the edge that I want to get to. When I do that, the value will automatically put itself into that box itself over there. In my link area, I want to work bidirectional, and let's take a look what happens after I do my calculation. If I were to go into simulate, you'll note that my toolpath works from the area where the geometry that I started from works all the way over exactly to that edge. Look at our simulation, and this time, as you see, when I zoom in, it moves exactly across the part, and also note that the links between each single path is in a radius. Now, another option we have here is I can go back into my drive boundaries, and instead of using right, I can say I want to go in both directions. But not only that, I can also go across instead of along. Now when I go in both directions, actually I have to pick the next area that I want to go to. So in my passes area, all of a sudden we have now also left clear offset as well as the right clear offset. I'll simply click on the button and I'll choose this line over here. And this time when I do save and calculate, you'll note that when I do my simulation, my toolpath will actually start from one edge and go to the other, and it will not start just from the geometry itself, work on each side and then work to the other side, but it will instead will have a continuous path going along the part itself, moving very smoothly back and forth, completing our entire area. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.